Here we're tackling one of those show that questions that often pops up in trigonometry, where they'll give you something and they ask you to prove it or verify it. Now, the problem with these questions is that often you're not quite sure where to start. You've got to really look for clues and then just sometimes sort of mosey along and find your way through them. So let's have a look at this. It says use the cosine rule, and it gives us the version of the cosine rule that we already know, which is the find an angle version of it. It tells us that we've got a triangle ABC, so there's nothing much there as a clue. Now, part one says we want to verify Pythagoras' theorem by taking angle A to equal 90 degrees. Now, in a right-angled triangle, you can use the cosine rule or the sine rule just as you could in a non-right-angled triangle, and it will all work out. Now, we already know that cos of 90 degrees is 0 and sine of 90 degrees is 1, and so they're nice round numbers that just work out really well. So we are going to verify Pythagoras' theorem here by saying, well, all right, if angle A equals 90, and we're using this, first thing that I would write, as you're thinking things, write them down. That way an examiner can see exactly what you're thinking, and that's really all that you've got to do when you're showing something. So I know that cos of 90 degrees equals 0. Now, if cos of 90 is 0, I can sub 0 straight in to this. So I'll say, therefore, now putting these three dots at the start of a sentence makes you feel pretty smart, and it makes you look quite knowledgeable. So therefore, and now you proceed to say what you know, I'm going to put a 0 in here. 0 equals, and now we'll just literally write down what they've given us, like that. Now, we're trying to get to Pythagoras' theorem, and we've got some stuff up here that looks pretty good. This stuff's in the way. So it's pretty clear we need to get rid of that. Now, your basic equation solving techniques say that if you don't want a fraction in your equation, multiply by the denominator. So pretty simple here. Multiply both sides by 2bc. That'll remove it from here, and over this side, 0 lots of 2bc is still 0. Okay. Now all we need to do is to get it looking a bit more like Pythagoras' theorem, let's add a squared to both sides. Okay. Now, we're used to seeing Pythagoras' theorem as a squared plus b squared equals c squared. There's nothing really wrong with it being written around like this, but what is it that you normally think of that c has that's special about it? It's the hypotenuse, isn't it? So this version of it is absolutely fine as long as we qualify the fact that we know that the a, little a, must be the hypotenuse. So just write that, where a is the hypotenuse. Now, little a is opposite big A, isn't it? And that makes sense. The hypotenuse is always opposite the right angle, and we know that big A is the right angle. And so let's just write that. A equals 90 degrees, okay? As required, it's finished, okay? So that's all you've got to do. Then when we get to question 2, let's rub this one out. It says, show that if angle A is obtuse, okay, so it's not 90 degrees anymore, different situation. If it's obtuse, then a squared is greater than b squared plus c squared. All right, where to start? We'll start with this. This is your clue. If angle A is obtuse, what are we doing with angle A? We're subbing it in here, aren't we? So start with that. Say cos A. Now, if A is obtuse, it's in the second quadrant. What do you know about cos in the second quadrant? It's negative there, right? All stations to central tells you that over here, only sine of an angle is positive, so cos is going to be negative. So cos A is less than 0 when A is obtuse. Now that's just my thinking, but by writing it down, it makes an excellent first line. Now I could have written here cos A is negative. Why didn't I do that? Well, I could have, but I wrote is less than 0 because that means the same thing. And look at where we're going. This is a clue. I'm trying to make a statement that's got greater than and less than signs in it. So starting out with one that's got one there is looking like a really great start. Okay, now they've given us this to use and we haven't used it yet. So that's your next clue. Okay, how can we use this? All right, well if cos of A is equal to all of that and cos of A is less than 0, then all of that must also be less than 0. So that's our next thing that we write. Therefore, again, feeling so smart, so b squared plus c squared minus a squared all over 2bc must be less than 0. Okay, see how there you've just, if that's less than 0, then all of this must be less than 0, because after all, you've told us that they're equal, so we can interchange them. All right, we're getting closer to looking like this. So you can sort of look at where you're going and see if you're going down the right road. Now, the next thing to think through here, we don't want to just solve this like we did in the first part by multiplying by 2bc. I mean, we could, and we get 0 over there. In fact, there's sort of two ways to do it. You could multiply by 2bc and say, therefore, b squared plus c squared minus a squared is less than 0. Then add a squared to both sides, like that. But I think that because we're showing that, I would rather actually put in some reasons here. And the reason that I would put over on the side, the reason that we can do this is, if you think about it, if this whole number on this side, because it's just a number when it all is said and done, it's all put in the calculator, it'll come out as a number. If that is negative, and it's a fraction, then either the top was negative and the bottom was positive, or the top was positive and the bottom was negative. One or the other, it can't be both. Negative divided by negative would be positive, right? So you can think this through here and just say, well, do I know anything about either one of these? Well, this could potentially be negative because I'm not sure how big the sides are, but look at this. B is the length of a triangle. C is the length of a side of a triangle. And if you multiply those, which have got to be positive because they're lengths, you multiply them by 2, this has to be positive, doesn't it? Which means this must have been negative. And that makes this line make a whole lot more sense. So you can put that in as your reason, because this is the last question in a paper often, and if they've said show that, they really want the reasons there. So you can put in brackets here, but 2bc must be positive, so b squared plus c squared minus a squared must be negative. Okay, now you've got reasons in there and you're looking like you've taken care of everything. And at the end here, have we finished with what they had? Well, pretty much theirs is just written around the other way. So you can finish off with your therefore again as though you've achieved something. A squared, it's on the big side here, so we can just rewrite it like that, plus c squared. And you're all finished.